Okay, looks like hopefully the stream's going. Can y'all hear me? Yep. Okay, all right. Probably need that. Chat's open. All right, so I'm gonna go ahead and get started here. So I'm eating dinner too, though I will say that I don't know. I'm trying not to take myself too seriously about like these streams, and so I actually did quite a bit of prep work for this stream in particular, because last week, though I had a lot of fun doing it, you know, I wanted to make sure that, like, if anyone decides to tune in, that there's going to be, like, the signal to noise ratio was going to be, like, worthwhile, and there's going to be, like, meaningful content on there. And, you know, I felt like there was a lot of, like, noise where I was, like, searching for a lot of different things. So I tried to at least, like, try to work through some of the kinks, and have, like, a specific goal in mind tonight, which was just basically I was able to get, I'm going to swap over to my scene here and ask my dog to not chew on her bone right now. 1 second. Though I have a feeling that she might just continue to come back. Anyways, where was I? So I managed to get this, which is basically these are just the integrations of the last 10 values just put on a line graph, so you can kind of see, you know, just basically, hey, like, they're real values, they're something. I don't know what they mean yet. It's been really interesting once I start seeing them on a line graph and kind of getting a sense of, like, what integrating you know, our stream of values, like, means. Like, it's still, though I thought, well, we'll get into that in a second. So this is where I'm going to try to be tonight. I don't know if we'll get to the UI portion, but definitely, like, the stream of values, right, that we see here in the console. Like, that's kind of, not kind of, that is our goal. So, oh, and I forgot to notify everyone. Let me do that real quick. Do. I'm not actually even sure. Is anyone? It's so hard to tell for me, and I just, maybe it's because I don't know Twitch, but if anyone's, like, actually watching or not. And you know what? I'm just gonna go ahead and get my music going too. Okay. So, yeah, as I said, I don't know if, ooh, this is kind of pretty, right? That surely means something. I don't know if we'll get to the UI tonight. Hopefully, maybe, I don't know, we'll try. But this is our goal tonight, to just get a stream of the integration of, like, the last 10 values of a price stream. So let's get going. I'm gonna open up Vim. Let's see. All right, it's not what I want to do. So code. Let's take a look at where we left off last week. All right. Okay, yeah, we can get rid of all these. I think I'm really happy with Coinbase's stream, though it comes in a little bit. Okay, wow, yeah. So we have two different, okay. So what I'm gonna do here is, what we actually are only interested in, let's go take a look at, yeah. Let's go take a look at our application. Oh. And let's see here. Okay, cool. So this is where we're at. So I kind of did a deeper dive into the heartbeat and kind of determined that I don't think it's really anything that we can use. So we're just going to filter it. I think we have to have it as a part of like our, or I think after reading about WebSockets a little bit, like a heartbeat's like a pretty common thing to do that the server does because they want to see if like the connection's still alive. So if like this fails, then I'll go ahead and like close the socket. So I think we have to subscribe to heartbeat. Otherwise the WebSocket will get grumpy. So we're gonna leave. So we're gonna subscribe to the channel heartbeat, but this is the only pair that we care about. So what we're basically gonna do is we're just gonna filter out all of the heartbeats. Now filter works. You're not actually like getting rid of values that match true here. You're actually only letting through values that match true here. But so I'm gonna get rid of heartbeat. Gonna get rid of. I don't want to subscribe to it. I'm gonna move this up. So, and actually, I'm just gonna simplify this a little bit. I'm also trying something a little different with the music this week. I got like a copyright notice that you get on like YouTube sometimes whenever you use like other people's music. So this is actually, I'm a musician in a different life, and this is just like basically sometimes I record my stuff and I'm just playing it so that way I don't get bugged by that copyright notice. But it's mostly just kind of filler and background noise, and it's not bad stuff to like focus to. It's pretty passive. It's a pretty passive listen. Okay, so go and do that. I'm just gonna collapse that so we don't have to look at it anymore. Okay, so the first thing that I think we want to do is we want to take our ticker. And so first thing we're doing is we're filtering. So let's do, just to make things a little bit easier, I'm going to do a deconstruction of the RXJS operator. So and I'm just going to put filter so that way we can do things like this. And so I know that I'm gonna need scan, and since I prepared a little bit, I know I'm also gonna need a with latest from. We'll go into Y in a little bit, or hopefully we'll get to a point where this will be useful. Okay, so here we are, we have our ticker. So the first thing that we want to do is, and let me get my notes up here, kind of keep things on the rail as best I can. Okay, yes, we want to get the price out of it. So we're going to create a selector to get the price. So now before, I happen to know that I loaded Lodash already on the page. And so again, we're going to deconstruct some values out of Lodash, just stuff that I know I use all the time. And we're going to get pipe and get. All right, and so, and this is composed, but it goes from left to right. It's a functional program trick. You'll see how it's used more in a minute. And getter is just, it's basically a lens. So it just creates, you know, it's a curried function, and it basically creates a partial application for like selecting a certain property in an object that you pass in as like the last argument. Well, because we're using Lodash@p, it's the last argument. So we're going to create a selector out of get. So let's do let price. You know what? I know we're gonna need it. I'm just gonna put tap in there. I know we're gonna need tap. Also, last comma life. I'm all about it. So get. I think it's called price. Let's take. Gonna need to turn that into a float in a minute. Okay, so price, and let's just map select price. So see how this goes. What? Whatever. I love when it does this. Yeah, whatever. Okay, so we'll get on that last comma life there. Get is not a function. What is it then? Oh, right. Load-FP calls it something else. What do you call it? So let's see, because it has like a list in here for the aliases. Path. It's an alias again. Maybe that's what it wants. Well, let's go back to my. So dot path. No, I don't like that either. Get. No. This, I wonder what version of Lodash we're loading. So let's do it. And yeah, whatever. Right. This is that. I ran into this like for whatever reason, like Load-FP definitely wasn't loading. So I'm gonna load it from somewhere else. I think was the moral of the story. We're gonna load it from where Lodash tells us to load it. Okay. Sure. So we still have RXJS, yeah. Okay, cool. So, and let's go back to our JS. So get should totally be a function now. Map is not a function because I didn't import you as an operator. That's why you're not a function. Also, favorite thing to do in the world, sort. Yeah, that's what I'm talking about. That way it's alphabetical. Okay, so cool. So one problem that I just know we're gonna have is it's not immediately obvious, but this is actually a string, and we're gonna do math with it, so it needs to be a number. So we are going to want to cast this to an int or a float, actually. So which is why I imported pipe earlier. So what we're gonna do is we're going to pipe. Log. Okay, and so all pipe is doing here is basically, so what the value we are getting here is going to get piped into parse float, and then the return from parse float will continue through the string. So that's what select price is going to do for us. Okay, let me check the comments, see if yeah, so if anyone, just please drop off a comment if like the music's too loud, or if, you know, I'm talking too fast, or if I said something that doesn't really make a whole lot of sense. Whoops. Or if you get really annoying feedback and you don't want that anymore. So what's weird here, suspiciously, it's cutting off at 2 every time. I wonder, let me just do a quick look on parse float. Yeah. I can't ever remember. There's one you have to pass like a radix to. Honestly, I don't know what a radix is. Okay. Seems like parsing a float from a string is a perfectly cool thing to do, so we're just gonna go with it, and just maybe that's all that's coming back from the from our. So let's see. No, we want a ticker. So here's our value. Let's look for price. Okay, it's just stripping the zeros. I'm cool with that. Okay. So here we are. We have our price stream, and so now is the piece where we want to. And I'm just kind of picking something out of thin air that makes sense to me. We're going to do an integration of the last 10 values. Let me just make sure this is what I think it is. I just key. Yeah, no, that is okay. Okay. So here, and let me take you through the journey that I went on Thursday night. I kind of had an impromptu. I got really excited, so I decided I was gonna do another like impromptu unannounced stream, and it kind of ended up struggling with RXJS the whole night. The learning curve on it's like definitely steep, but I learned a lot of like really good things. So things started off with buffer, and then this problem where the page doesn't refresh. Yeah, so what buffer does is pretty neat, and so let's use it just to kind of like get a sense of like what it does. And so what you do is for buffer, you have buffer and you pass in a number, and what it's going to do is it's going to hold on to the values, and then it's going to emit an array of the last n values, whatever you pass in as a count. So let's play with that. So I am going to, first of all, I'm going to scope a variable here called, for no particular reason, because I like to, it makes me happy. Because this is not going to change. So I'm gonna do, yep. All right, let's see what we get here. So I'll let you know, this takes a little while to show up because it's got to get 10 values. So you know what? Yep, there you go. So the problem with buffer and why I couldn't ultimately use it is that well, if you notice, unfortunately, okay, so if you notice, the first item here and the last item of the previously emitted are not the same. So, and which is probably actually expected behavior in like both cases. But what's happening here is it is waiting, is collecting 10 elements, and then it is emitting them. So, which isn't exactly what I want. I want the first value emitted, and then when the second one comes through, the first an array of 2 values emitted, and I want that all the way up to 10. And so once we get to 10, what I want is for the last 9 values to be emitted, and then the newest value to get emitted, or to be just stuck on to the end there. And so it's, I think I've heard it referred to as a circular buffer before. And so it just sits there and it just cycles through, you know, at any time you go and grab the values from this observable, you're going to get the last like 10 values. And so, and what I basically want to do is I want to run our integration for each new value that comes in, integrate the last 10 values. That's kind of my algorithm of choice for whatever reason. So buffer count wouldn't really work because, you know, this is 0 through 10. Or I'm sorry, 0 through 9, and then this is 10 through 19, or, you know, and so, and that's not what I wanted. I wanted 0, you know, 0, and then 0, 1, then 0, 1, 2, 3, and then all the way up to 0, 9, and then 1 through 10, if that makes any sense. Okay. So then I found window. So window seems to, I actually think that window might be what, if I want to do this in like where it wasn't necessarily holding on, like it would emit at like regular intervals, which I think is good. Well, which is one piece of the puzzle, right? But it was still, it wasn't emitting every value. It was only emitting every time the count was hit. And basically, I just wanted the count to be like a take, right? But take wasn't working either because basically this was only emitting once it completed. It wouldn't continue emitting the last 10 values. And so, which was kind of, I was trying to basically piece together like, okay, well, how can I use take in a combination with buffer and window? And I was getting myself pretty good and turned around, which is when I saw just a blog post that was just like, just use scan, right? Now scan, and okay, and I'm not gonna lie, I know that scan and reduce, in my mind, scan and reduce are the same thing. That's probably not right. But however, I think that they are very similar enough to where, you know, I don't know if you could replace one with the other, but whatever. I use scan because it does a similar thing to reduce us, where it's meant to, you have an accumulator and you have the current value, and you basically are able to do a summation over like a series of values, which is exactly what an integral is. But we're actually not using scan to calculate the integral yet, or I didn't end up doing that. This is the only thing that we are doing here, is we are basically hanging on. We're hanging on to the fact that our accumulator here is basically state, and that we are adding values as an array to the accumulator, and then we are removing values from the accumulator once we get beyond like our threshold. So that's what ended up working for me. It worked pretty well. I was pretty happy with it. So I'm sure it probably like thrashes memory, but whatever, it works. I'm gonna use it. Okay, so let's get rid of buffer. And let's start our scan function. So I happen to know, or one of the pieces that was needed was all the items that were passed into scan. Okay, let me take a look back at my notes here. Okay. Okay, so what we ended up wanting, so let's start with highlight it because I'm losing it. Come on, where you at? There it is. Okay. Do that. Okay, we have our accumulation, and then we have our current value. So I know that, so this is going to be our price, right? And so what we're going to want to do here is we're going to, first of all, let's start, we're going to initialize our accumulation as an array. Do we even need to do that? I don't even, you know what? Let's try not doing that. Normally I like to initialize reduce with a value. Seems like just kind of like a good habit to be in, so that way you don't accidentally call like something silly. But let's see. So I know for a fact this will work. No. Okay, so what this would do is this would, I mean, this is actually, this spread here is kind of superfluous. But this will return an array of the current value. So, but we want to take all the previous values along with it. So I think what we want here is we actually want to do a spread, right? And so what this is going to do is this is going to take all the previous values. And so let's see what this does. I know that one of the things that we're going to need to do is we're going to basically need to get rid of the head of, we want to get rid of the, we want to return, right, like 1 through n, where n being buffer size of our previous value. So we're gonna have to do some slice magic on this, but let's just, for this I would expect this to just we basically are reinventing the wheel of the observable, and we're just going to get an array of the values from when our observable started emitting. But let's just to make sure that we understand what's going on here, let's just verify that this is true. Oh. Oh. Remember whenever I said that you should totally initialize whenever you do a reduce? Yeah, this is why. Because we're trying to spread undefined. So for the first value that comes in, since we don't have an initial value, we spread on something. I don't know. Okay, so now for the first iteration, we have an array here. Okay, cool. Now, what we're quickly about to realize, I'm gonna check the comments. Scan is just different than reduce. They're very similar, but I don't think one is necessarily better than the other. And honestly, the subtleties and the difference between the two is, I don't know, to be honest. But conceptually, I think that they are the same, and probably the underlying mechanics are different. But so we're gonna quickly realize here that we basically just created a wonderful little memory leak. Like, this array is gonna grow without bounds. So let's let's do some magic here. So let's do a slice. So we don't want the first value, so we don't want 0, right? So the way slice works, MDN is this is going to return a copy of the array. It doesn't mutate or anything like that, but you give it the beginning index and then the end index. So I think right, this would this basically returns the whole thing. Let's see. So far, so good. I really like checking to see because I get a second to continue with my dinner. Okay. I hate when it emits the same value a lot. Makes me think it's broken. Okay. So I think what we want is we actually just want to go. Oh wait, no, we want to. Hang on. Okay, right. So we're correct. We do want the head of the array gone. So this 0 needs to turn to 1. Right? I don't know. Let's see. So now we should get all the way up to, and I'm going to turn my buffer size down so that way we don't have to wait. So 3. So okay, this obviously didn't do what we thought. Why not? 0 begin to end. Let me check my note. Yeah. This not. Yeah, it's doing the same thing. Huh, that's interesting. I wonder if that's because does it ever? Okay, it's just giving us the last value. So we're losing. Oh, right. That's okay. And so, like, that's correct. This is only giving us. I know, this is kind of like a really roundabout way of just returning an array of the last value. So I think what we want to do is for when we are underneath our buffer size, we're going to need a little bit of logic here. So I think what we want to do. Okay. So we can't just do n like -1 or something like that, right? Because like, so the first one, or wait, whenever I say n, what I mean is buffer size. So like 3 minus 1, that's 2. So 2 is greater than length. So this is not, this would not work. So I think what we're gonna need is we're gonna need to clamp it. So this is a trick. For anyone, this is actually a pretty common trick in the, or I don't know, I use this all the time, where you clamp a value. So basically what's going to happen is anytime we're underneath our buffer size, that we're just gonna go to the beginning of the array. But as soon as we are, actually, hold on, I think we want right, hang on. So this is gonna say, so it's either gonna be 0, but let's say, okay, let's say our array length is 2. So this is gonna be 2 minus buffer size, so it's -1 minus 1, so it's -3, so that's gonna clamp. Let's say once we get to it, our length is 3 minus 0 minus 1, which is gonna be 2. That seems good. So we're gonna go from 2. Oh crap, what did I say length was? So let's see, it's 2 minus 3, which is -1, 1 minus 1. Okay, so 2, but 3 minus 3 is 0 minus 1, which is -1. So that's going to be 0. So we'll go from 0. Okay, and so whenever we get to 4, so where our length is 4. Wait, hang on, this needs to be ACC. Let's just try this. Then we'll run through it later if it works. I'm hoping the next value, this 56, comes up here. No, it's not. Okay. Well, something's not quite right. We have 1, 2, 3, 4, 5, but our buffer size is 3, so we should only have 3 values. What is that? Okay, so, oh, because you know what, the accumulation, right, so let's say length is 3 minus 1, -1, so it's going to get clamped, and we don't want it to. When we're at buffer size, when we're at a length of 3, we want to replace first value, right? Well, we want to return the last of the array. And then append the value to the end. So this should actually, am I 3 minus 0? Oh my god, I'm so stupid. Okay, yeah. So 3 minus 3, 0 minus, no, wait, shit. I actually was right. But we don't want -1, right? We want, in the case of 3, we actually want the answer to be 2. Which is making me question my whole approach here that I have written out in my notes. I wonder if this even worked. Okay. So we get 5 values, so it has to, and which makes sense because length. So we take out 0, then we have 0. So when, oh, so we have 3 values. We want to return 1, so 3 minus 3. Is it plus 1? Maybe? Let's try this. Seems wrong, but... Okay. Man, it's really hard to tell if it's working when it keeps emitting the same values. Like, is it emitting the same? And like, did I do this wrong? I'm pretty sure I did this wrong. Okay. This would be a great thing to unit test, actually. Well, and this is actually kind of one of the things that I wanted from the stream is to see the struggle. Okay. Unless we ever see, oh, we do see different values come in here. Man, this is what I'm talking about. So, I wish, okay, so how about, and then I guess, I don't know which ones, okay, these are the latest values. So, where's our price? 375.23. Okay. I'm just gonna go out on a limb and say that this is working. I'm sure that whole sequence was extremely frustrating to watch on the stream when you're just like, just add 1. And did anyone drop anything off in the comments where it's like, just add 1? No. Okay. Okay. So, what did I set this to? 10? Okay, let's see if it makes it all the way to 10. Check our logic. Yay, we made it. Okay, let's... So, 37589, where are you? So you're here. So you're eventually gonna make it all the way to the top, right? Yeah. So look, doom, 37985. He is slowly trucking his way to the head. So, it works. We should really unit test this though. But, whatever, I'm coding in fantasy land right now, so I'm not writing unit test. I mean, I should write the unit test. I'm not going to. I don't want to pull in full unit test framework. It works. Okay. So, and basically we have succeeded. We now have a buffer size in which what we are going to want to do is we are going to want to integrate these values, right? So, which brings us to the trapezoid rule or the trapezoidal rule. Okay. So, I spent a long time like digging into like integrations, and I was like kind of surprised that it wasn't as straightforward. Like calculating integrations like wasn't quite as like straightforward as I was like hoping for. And it kind of makes sense because like one of the inherent natural things about an integral is that you cut something up into like an infinite number of slices, right? And so like you obviously can't do that on a computer because you don't have like infinite memory, right? So it seems like that, but the math world, you know, they don't really care about that. They're like, sure, you can do infinity, and they continue trudging on with the assumption that infinity is totally infinite, an infinite set of values, and being able to slice things up infinitely is totally possible. But for those of us in the real world, also known as engineers, we have to deal with approximations. Was kind of my read, and there are a lot of different ways to calculate the approximation, that's what the little squiggly lines mean, for an integral. So let it be known that, well, let me start with like a review of what an integral is and why we are trying to use it. So, and as a review from my last week, the greatest thing ever is just when you're on a science article, just type in simple as the subdomain and then it puts it in English. And by English, I think I mean like something that something that's a lot easier to understand than what Wikipedia math-related Wikipedia articles tend to do. Okay, so what we are trying to do here is we want S. We want to calculate S. We are calculating the area underneath the curve for our price stream. So f of x here is our price stream, and these values that are independent variable is whatever's on the y-axis. That is going to be our price. It's going to go up. It's going to go down. Right, and we are actually doing numerical analysis on the price stream. And so as it goes up and it goes down, our dependent variable, which is our time, right? And so integrals, they're not always functions of time, I don't think, but this one is, I don't know. Like it's, yeah, like I can't think of a time that I've run into an integral where it wasn't a function of time. So the x-axis is almost always time, almost. So, now if you remember, so anyway, so for each value, we actually need to track two things. Now I'm sitting here thinking about it. We need to track not only the price, but the time, right? What time did that price come in? Because we're going to need that to calculate the interval. Ah, right. Which is where with latest from comes from. So what we're going to do is we are going to set up a second observable, which is going to be our, I'm going to call our x-axis. And let's see, it's not, no, I think it's not an operator. It's totally a way of creating observables. So it's just on the RXJS object. Interval, and then I think this is milliseconds, so let's do 1 every second. Okay, and so what we're gonna do here, let me check my notes. Yep, that's what I thought. So now how did where's my selector? Let me make sure I got this right for buffer. Oh, that's fine, and that's right, the values are gonna be, okay. So I'm gonna do with latest from interval. So what's gonna happen here is every time ticker emits a value that makes it through the filter, because we don't care about the heartbeat, what it's gonna do is it's actually going to, that is happening separately, asynchronously, if you will, from our x-axis interval. So what's happening is this is just going to emit a number every, I think an integer, every second. And so it is a stream in and of itself. We're actually combining these two streams, and that's what with latest from does, is it is a combinator. So if you come here, if you go through the RxJS documentation, you'll notice that the operators are broken out into these nice little categories. And so for combination, with latest from. And so yes, with latest from does exactly what you would think to provide the last value from another observable. So what's going to happen is when a value gets emitted here, whatever the last value that was emitted from our x-axis, which is just going to be a number, right? We are going to create a pair, I believe. So a pair is an array of two elements. And one will be the interval, and then the second is going to be the price. So I hope. Hang on. Actually, I think this needs to come second. Right, so the price is going to come out. It's going to go, and with latest from is going to create a pair where the first item is going to be the price, and then the second item is going to be the latest value that was emitted from our x-axis. All right, let's take a look, see what we got. Cool. So this is way less cool to look at, right? Because you have to do this. Okay. Let's see here. That's interesting. Oh, this is gonna be, yeah, because these values change, but we're still in the same second. So maybe we want to increase the resolution a little bit for this. So let's do maybe 100 milliseconds instead. Okay. Well, you know what? I'm not going to get too hung up on the details here. What? Or maybe, you know what? I wonder if it just didn't pick up the new. Sometimes that happens. I get excited and it doesn't work. I'm suspicious. These numbers seem suspiciously low, because if this is in milliseconds, then, you know what, as fast as you can. Which I think is in milliseconds. So now our x-axis, yeah. Okay, cool. This makes me happier. Our x-axis is measured in milliseconds, so we'll probably end up going back to seconds. I don't know, it's whatever. So, okay. So here we are, we have our y value, we have our x value. And they're all sitting in this nice pretty array. So one cool thing to do, well, actually I don't want to get distracted with that. It's a rabbit hole, kind of going somewhere else. Okay. So now, I think we have, this is, as weird as this may look, this is actually like this actually is f of x, or this is our graph, right? So if we wanted to plot this onto this amazing thing that's been running the whole time in the background, wow, that's interesting. If we wanted to plot this to a graph, we could right now, and we probably will. It's going back up. We probably will at some point. We're probably going to need this exact thing that we have built with the price and the x-axis. But this is about taking an integration approximation from this whole shebang. So let me check the comments. Nothing. Got 2 people watching, both of which are probably me, which I'm happy with. Okay. So where was I? Right. So we're going to create our trapezoid function now. Okay. So let's go over what the trapezoid rule is. So we have, okay, so taking what we know from the integral, here is a area underneath the curve in which we want to calculate. And so all the trapezoid rule is that if you break up your function into a bunch of trapezoids, then, and calculate the area of the trapezoids, then you have an approximate area for your area under the curve. So there's going to be a degree of, like, if you notice here, right, we totally lost this area because of this. And so the idea here is that, you know, even though mathematicians can totally do things like infinitely, right, and get like the perfect area underneath like this curve, like engineers usually try to figure out a good enough point that are living in the real world. So basically, the more trapezoids that you create underneath your function, the more accurate your approximation is going to be. Now, we are going to calculate, we are kind of bound anyways, right? Because our f of x isn't like a true f of x. Like it has an indexing of its own, right? Like if we tried to get the value for, you know, if we have a value of 0 and a value of 1 in the 0 and 1 section or indexes of the array, like we can calculate the area between those two values, right? It's just going to be a triangle, but and if we tried to calculate in between the two known values, then it would be an approximation anyways. You can do something called a linear interpolation, or just interpolation, right? To get a value in between like your two known values, to say like, oh hey, like it, you know, it's probably right here. But we're not going to do that. What we are going to do is we have these finite points like along our function, and we are just going to calculate the area of the trapezoid for basically for our buffer size. So right now it's 10, so we're going to create 10 trapezoids, and we're going to calculate the area of it, and we're going to call that our integral. So before we get into this, because this is kind of the fun part, or the part I had the most fun with, is converting this into code. Let's take a look at what the area of a trapezoid is, and like the specific, because this formula is actually kind of important. So first of all, really nice, you type in area of a trapezoid, right? Google, like, it's like, oh yeah, here you go. So it's important to note, well, not important to note, but let's take a look at it. So what's going to happen here, and I wish I could like turn it, because like what we want to do here is A is actually going to be on the left, B is going to be on the right, and H is going to be along the bottom. And then looking at this, so looking at this formula, we have A plus B over 2 times H. And so basically, so A is going to be our price, you know, on the left. So if we're iterating through our array of values and we're at 0, right? A is going to be the 0 index Y value. B is going to be the 1 index Y value. H is going to be the difference on the x-axis. And so it is going to be, the 1 index, or the right value, the 0 value, which is going to be what comes from the interval, minus the previous value, what came from the interval, right? And so we're going to subtract these two things to get the length of how long it's been on our x-axis. And so that's how we're going to calculate our 3 variables. And then we have calculated the area for underneath the curve for our trapezoid. And all we're going to do is we're going to add up all of our trapezoids. So it's a pretty simple algorithm, and it's kind of cool. It was really fun to reintegrate. So looking at that, here is, and I read through all this. All right, so let's walk through the equation, right? And so this is the definite integral. This has a name. I forgot what it is. It's like the king of all integrals, or something like that. I don't know. This thing's really important. You see it all the time. But anyways, so from A to B, you know what? I don't want to go into what this is. You can look it up later. But the important part is like, so is approximately equal to, and then here's the good stuff. Here's the stuff we can write code from. So anytime you see one of these big E's, they're my favorite things in the world, because this is a for loop. This is exactly... Okay, I don't want to say that like for loops like came from this or anything like that, but anytime you say this, it's like, okay, we're iterating, right? And then every time we iterate, we are just adding that value up with the previous value until we get to the end. So, and you should be pretty familiar with this. So, and what this is saying is we start at 1. So we do have to make a couple of changes because we start at 0, right? So k is the same as I. Anytime you see like a for loop and I equals 0 and you increment it each time, that's what k is. N is usually you'll see like an array.length or something like that, like however many times you're going to loop through your sequence. So that's n. So, and here we have a, which a here is, since we are starting on 1, this actually like looks back. And so basically it's the first value that that this starts with is the right side of the trapezoid here. And so we're going to change that a little bit because we're actually going to start with the left side of the trapezoid and we're going to look to the right side of the trapezoid. So you can think of this as, this is going to be our f of k on this side, and that's going to be a, right? And then it's going to be plus f of k plus 1, which is going to be the right side of our trapezoid, which is going to be b, right? And so divide by 2, and then we have delta k, and so that is exactly what I mentioned earlier, which delta k, this means change in k, right? So on the x-axis. And so this is going to mean our k on the right, it minus k on the left. So that's how much the x-axis change. Anytime you see delta in k, it's always going to be a difference of 2 terms. Yeah, in fact, it looks here. X of k minus x of k minus 1. Okay. So let's go and implement it. So I'm going to make some space for myself here. So I'm going to say that I want this to take in our array of values, right? So our buffer, and I want it to return a number. It's just going to return a number. All right, so array. So, and I'm just going to go ahead and give myself a closure here. Honestly, and John, if you're watching the screen, you would know how much I hate that I have to do this. Because I try to keep everything, what is it called, expressionless, expressionful. I don't know. I like the implicit returns of the arrow function. I try to use them as much as possible. I always feel like every time you introduce a closure, somebody, including yourself, is going to abuse this closure. And they're going to do something silly with it. But I digress. So we're going to return. So we have our array. So this is a reduction. So yeah. You know what? Actually, yeah. So since like we're taking in a list of things and returning a number, you can immediately identify that as an array. So we can't use scan because this is an unobservable, but this is an array, so you can use reduce. Okay. So I know that we have our accumulated value, we have our immediate value, we have the index we are currently on. So this right here is going to be k over here, sort of. That k equals 0 in our case. And then we have the original array. Do I want to use that? No, I don't. Okay. Now I'm going to give myself a closure. And you'll see why in a minute. Which I'm glad I prepped because I would have gotten stuck on why I needed this closure. And yeah, so I actually you know what I'm gonna do? I'm actually gonna run through how like I solved this whenever I was screwing around the other night. Because I don't know, it makes a lot of sense. So what we're gonna do is we're gonna have results. Right. So what I want to do is I actually want to grab the value for each. So all we're doing here, once we're inside of this reduce, right? Once we're inside of this reduce, you know, we are actually inside of here, right? So like we're taking this out of the equation. So whenever we implement and reduce, we basically accomplish this part of the equation. So now we're on to this part of the equation. And so what I'm actually going to do is I'm actually going to make a variable for each one of these terms. So this is A, this is B, this is H. So I'm going to let f of x, you know, let's make it A, let's call it A. It's equal to, so it's important to remember here that we have, it's kind of funky, but we have an array of arrays here. So let's take, and what we want is our current value. And so now our 0, right, if we go back to here, our 0 index, so right, looking at this, whenever we're on I, or we have I, right, we got this bad boy, this element, so we have an array. So our 0th element is going to be our y-axis, so, or our price. So we want, so for A, which is f of x, and our A value, or our left value, and it's the y value, or this value right here, of x. So that is going to be 0. So that's A. You know what? I'm going to call it f of x. So then now let's get this value of x less 1. Our next f of x, I don't know. So ACC, and then I plus 1. We're gonna come back to this. This should immediately jump out to any seasoned programmer is, hang on a minute. And 0. So now we need our x-axis values. So let's get x on the left side. So let's call this just x equal to ACC, our first index, but is going to be 1. So we happen to know, yeah, 1. So right now, like looking at our array here, so this is our f of x, this is our f of x plus 1. Now this is going to be our x, and this is going to be our x plus 1. Next, I'm going to call these next. I don't like, actually gonna, so, well, okay, so, and actually result, this is terrible because like we're not doing, or, okay. So first of all, I just broke my rule of ACC doesn't have a value, so an initial value, so let's give it, for when we're initializing it, it's going to be 0. Results here, this is terrible, so I'm going to get rid of it. It was a bad idea. But what we want to do is we're going to return our equation here. So let's go with, let's take a look here. So f of x plus f of next x. So x plus f of x next. Then we are going to divide by 2, or just a random scalar hanging out there. So, and actually, I'm like Mr., you know, if there's like a stereotype of mathematicians or programmers. I'm Mr. Always wrapping in parentheses because wrapping things into parentheses is easier than remembering order of operations. So just, yeah, make fun of me. Okay, so now we're on to this piece, the last piece, which is our delta k, which is going to be our right x value, which is going to be... Oh, we never did make it. Wait, what happened to... Did you disappear? Where'd you go? Oh, there you are. Well, why did you... Okay. Oh, maybe I... Oh, I never did. I never made f of x. Or x and I never made x. Okay, let's make x. I1. Okay. So, now we want to subtract, so we need x of next there. And then minus x. Okay. So this is going to return our area, the area of our trapezoid. Then our reduce is going to add them all up. Okay. And this is totally not going to work, but that's fine. Let's see what happens. Let's let it blow up. Blow up, yo. Oh god, you should have blown up. Why aren't you blowing up? Wait. Oh. Yeah. Right. Okay, so we need to wire trapezoid into our... So what we're going to do is we're going to do the old map function, and we're going to map our trapezoidal. I never did use value. Oh, right. Wait. ACC? No. This needs... I'm sorry. This is not the accumulation. This needs to be the array. Probably auto-completed into that. Okay. Yay! Okay, so what... So, here we go. Cannot read property 0 of undefined. So it's saying, hey, look at this. We're outside of the bound. So basically, the first value came in, but you can't see that. The first value came in, and so our initial array has a length of 1. And so this goes and looks for 2. Right? The second, or I'm sorry, it goes and looks for the first index, or the second index, but it index number 1 of the array. So this is 0 plus 1, which doesn't exist. And then we try to access the 0 index of that, and then, which doesn't work because it just doesn't work. So what we do, which is why I created this closure and not a beautiful expressionless, I don't know what to call it, arrow function. Hey, Miss Sunny. So we're gonna say if wait, why did I do this? I'm looking at my notes here. Let's run through. What is 8? No, right. Okay, right. That's right. You know what? Let's just let it blow up again. So what we're going to do is say when I equals 0, what we're going to do is we're just going to return everything the way... Okay. No, this doesn't work. Hold on. Okay, so we want to return... So if we only have one element, because we need 2 elements to compare. So if a dot length is less than 1, 2, less than 2, then basically this is just going to return 0, but okay, so return 0. Probably bad. Okay, see what happens. so 0, cool. Oh, what happened? Actually, again. So you know what? I'm gonna turn this on. See what happens. Check comments. Nope. I told you to pause though. No, I want you to pause. Pause on everything. Cool. So let's take a look at our array. Oh, right. Right. So here's what happened is on the second iteration, when I equaled length, our length of our array, which is going to be 1, basically, as we are, because we are wanting the pairs of everything, this is like slicing bread, like of a problem. Like we have 10 slices of bread, but that means we only have like 9 cuts, right? So basically what we need to do is, since we're starting with 0 and 1, whenever we get to the second to last element, not the last element, we're done. Because once we get to the very last element, then there's no next trapezoid to calculate. So that's what we're going to do. So when we are currently on, so when I is equal to array.length, and we don't want to return 0. That would blow out all of our hard work. We're going to return everything we've accumulated to. Our current accumulation. So. Whoops. Hey, it's still collecting values. This is so interesting to me. Anyways. Yep. Okay, let's see what. Okay, it's still blowing up. If I equals array.length, so 1. Alright, well, let's go again. How'd you get past? So let's take a look at I is 0. Okay. No, duh. This is when it's equal to the last element. Return. Well, so. Oh, right. So when it's equal to return what we've accumulated. Huh. So. Oh, right. This is we're on 0, but our length is right. So we have to, okay, we have to current, this is a number and this is an index. We have to convert this number to an index, which is just subtracting 1. So I've actually seen a JavaScript proposal where if you take off the H, or okay, there's not an actual proposal, but man, I would love this if this was actually just length minus 1, because you end up converting from an index to a number quite a bit. So this should be good to go. Uh-oh. Uh-oh. What? How's it not? What did I do? Okay. So, here's what I'm gonna do. Stick in a debugger. Why? So, f of x, f of next, x 56, 56. So, something, right? So So I mean, if we multiply by 0, right, then we're gonna get 0. Something's not right. What is... Oh, duh. See my bug? All right. So, kind of made it through that faster than I thought I would. We have time for the UI. Aw, what is this? This is kind of all over the place. I wonder if this is like actually work. I have no way of testing this. So, where like, if I were really serious about it, like, probably put in some unit tests and test my functions against known values. Maybe I'll do that next week. Or maybe I'll do that now. I mean, I say these numbers look wrong. So this looks like we might actually just be, let's see. Well, it's just gonna do a lot after that. Yeah. So if I'm really serious about this. Well, okay. So here we are. We have, let's get out our trusty Excel spreadsheet. Right. No. Ooh. Okay, let's try. Let's get our trusty calculator. So right, this is A, so 37, 9, 7 plus B, 379.26. This is on top, so we divide this by 2. Okay, so I'm just gonna put that somewhere. Okay, so then we have 607. 7 minus 6 equals about 41 times this bad boy. Oh no, shoot. No, what, 3? Oh man. Okay, so this isn't the greatest place to put values. Nope. Okay. Got that. 541. Hey, Sonny. Hey. Okay, so then we have, so A is 379. Nope, that would have been bad. 379.27 plus 379.6 equals divided by 2 times 541. 205,182.365. Okay, so we're calculating the first trapezoid, right? So how deep do we want to go on this? Also kind of gives you an idea of the kind of... Okay, so we have this. So let's calculate the second trapezoid here. So we know this one's correct. So 379.26 plus 9.27 divided by 2. 379.5. Wasn't that what it was? 379.265, that sounds correct. So let's clear this out. 683 minus 607. 76. So 76 times 379.265. I already forgot what the other thing was. God. I am really... So, sorry. A little spacey. Gonna do this again. Stick with it. It's not gonna defeat me. I don't know, it might. 76 times 379.265. $282.4414. Okay, so I wish we had an Excel spreadsheet. We don't. Whatever. So why is this 0? Oh wow. So if we get a ton of values of the same, that shouldn't be right though. Right, that shouldn't be 0. That should be whatever. This is actually pretty easy to calculate. So taking, I mean, if you take this one value that's different, right? It should be 379.7. So that, and then divided by 2 is just going to give you this value. So 379.27. So then we're just going to do 4895 minus 683. It's going to be a change in x. So 4212 times 379.27. It should be that, not 0. Okay, so something's definitely up. Seems like it comes in somewhat periodically. Huh. What in the world? So we're gonna make this thing so noisy. So this is why I like breaking things out. X. Next. We're just going to print out all these things for debugging. X next. This thing's going to be noisy. Alright, but what we're going to do is we're going to wait. 62 seems weird. Just going to wait for a 0 to show up. Oh, wait. Right, this might be hard to kind of parse through. Hang on. So what is this? Console.root end? Is that thing? I don't even know. It totally is. Alright. Let's just sit here and wait for a 0 to come in. Do our respective dinners. Alright, well, it's gonna get pretty noisy. I should probably put what iteration it is. Do that real quick. That'll be helpful. This is what I always imagined my stream would be. Just me eating cereal. Everybody watching a stream of numbers fly across my screen. It's not cereal though. And who am I kidding? Nobody's watching this right now. Oh wait, 2 people. What? I wonder who, or one, that's probably one person. I don't know how to see. I don't know how to see who's third people watching. And I really hope a 0 didn't fly through. I feel like something's definitely wrong. Wonder. I'm gonna get to 8 iterations. That's not right. Oh wait, yeah it is. Okay. Well, of course it seems to be behaving correctly now, but something's definitely wrong. There's no way we should have ever gotten a 0. Well, except for the first value. Or what's another way we can get 0? I mean, if we have enough values emit at the exact same time, there's no way that'll happen, since interval's happening at next tick anyways. Okay, we're gonna call this good. Which is a really bad idea, because we totally saw a wrong value fly through. But again, whatever, I'm having fun. I'm in fantasy world right now. Okay, so here we are. Let's map this to a stream. So let me look at my notes. How did I do this? I actually don't want to do this, because what I did is that horrific. It was definitely like a hack and slash job to get this up. And maybe that, you know what, honestly, and I think that that's what next week is going to be, is because I kind of need to get my head into the charting space anyways, because that's what I'm doing at work right now. And I really feel that just a graph of the integral is actually not all that useful. But if you can see it in relationship to the price and what the integral is telling you about a point of time versus what the price is telling you at a given point in time, I think that seeing the relationship between those two things is like what is interesting. And so, yeah, I guess that's going to be next week. So I'll call it a night here. And then, yeah, I guess we'll get into probably some more UI, or, you know, next week is going to be building a UI for this that actually is like pretty neat. So, and any bug fixing that may come from. And honestly, I might actually bring in a unit test framework and actually unit test these to try to debug that error. So I might, you know, do that outside, because like I didn't want you to have to sit here and watch me set up a unit test framework. Or maybe, I don't know, is that something that's interesting? Yeah, so leave a comment, send me a tweet, send me a text message, because Lord knows I'm only talking to like one person right now, which is fine. And, you know, and let me know if you would like to see me set up a unit test framework, or if you'd just like to to see me actually write like unit tests. But yeah, thanks for tuning in, and a small and minor plug for all the music that you have been listening to has been my music, and a way to try to avoid the copyright stuff that YouTube sends me. Mousy doesn't have an E in it. So Mousy Magazine, if you're interested in the music that I end up making, I do have an EP coming out soon. Well, I say soon. It's off at the presses right now. So, but I also have a MySpace. I'm just kidding, I don't have a MySpace. But I do have a YouTube. And so it's just, you know what, I don't want to do that. But anyways, so if you're interested, if you like this music, or if you're interested in modular synthesizers, feel free to hit me up. All right. Thanks a lot, and so long. Oh God, I'm not gonna be able to stop the stream. Okay, cool.